Hello sir, it's me Mani Sharma from Group 3. Thank you so much for this opportunity. This project or the assignment is really very interesting and challenging too. So I'll try my best to complete this. So without further talk, I'll go to the question. And the question is, find the axis tangent at vertex, equation and length of latus rectum and the coordinates of vertex and focus of the parabola given below. So we are given the equation of parabola and told to find all those things mentioned above. So if we look at the question, from the first three terms we can find out that these are in a perfect square. So writing them, so we can write it as 3x minus 4y whole square, and I'm taking these terms to the right hand side. We can get 50x plus 100y minus 225. Now since we look at the left hand side, inside the square bracket we can see two terms, but so we have to further make it comparable to the standard form, and the standard form consists of three terms inside the square bracket, and to convert it into that form we have to introduce a new term. Let us suppose it as lambda. So I'm going as 4y plus lambda, so I'm letting here as lambda. Since we have introduced a new term to the left hand side, so uh, on expanding this we might get some new terms having lambda in them, which is not present in the original equation. So well, I'll show you. In the previous classes or in the smaller classes we might have learned a minus b plus c of whole square, which is equals to a square plus b square plus c square minus 2ab minus 2bc plus twice ac. Now if we expand this we will get 9x square minus 16y square, okay, plus here, plus lambda square minus 4 to the 12, 24xy minus 4 to the 8 lambda y, then plus 2 3 3 to the 6 lambda x. If we clearly look at these terms we will find out that there are some terms which are unnecessary and not present in the original equation. So what we have to do is we have to omit these equations, no, these terms, sorry. Lambda square, this and this, these are the three terms which is needed to be omitted. So what I'm going to do is I'll simply add these terms in the right hand side in this equation. So I can write it as, so this equation comes here, 3x minus 4y plus lambda whole square equals 50x plus 100y minus 225, and I am adding these terms, lambda square minus 8 lambda y plus 6 lambda x. Now this will balance the whole equation. Now this is still not the end. On moving further we will get, I'm keeping the like terms together. So we have 6x 50, 6 lambda 50, 6 lambda plus 50 50 times x plus 100 minus 8 lambda times y minus 225 plus lambda square. So let it suppose it as equation 1. Now what we have to do is we have to find the value of lambda, and for that I'm supposing the left hand side as equation 2 and the right hand side as the equation 3. So let's do that. 3x minus 4y plus lambda equals 0, this is the equation 2, and 6 lambda plus 50 times x plus 100 minus 8 lambda times y minus 225 plus lambda square equals 0. This I am supposing as equation 3. So what we have to do is we have to find the value of lambda, and for that uh, we are taking oh no. So we have to find the value of lambda in such a way that equation 2 and equation 3 are perpendicular to each other. And since equation 2 and 3 are perpendicular to each other, so what we have learned earlier is the product of their slope is equals to -1. And so first of all we have to find the slope of equation 2 and equation 3. So I'm drawing this. We are keeping equation 3 and omitting all. So we require this equation, these two also. So the equation of slope of equation 1 is slope of equation 1. We know that slope of any equation can be, suppose the equation is ax plus by plus c equals to 0, so its slope equals to minus a by b. Similarly, using this method we can find out the slope of equation 2 and equation 3. Oh, sorry, it's equation 2. So the slope m1 equals to minus 3 by minus 4, which is 3 by 4. Similarly, slope of equation 2 is equation 3 is m2 equals minus 6 lambda plus 50 by 100 minus 8 lambda. And now m1 into m2 equals -1, so we will get 3 by 4 into minus times 6 lambda plus 50 by 100 minus 8 lambda equals -1. This minus cut. So on solving this we will get lambda equals to 5. Now this value of lambda can be substituted in the equation 1. So substituting this we will get a new equation which will be used further. So I'm substituting this value of lambda in equation 1. So we will get 3x minus 4y plus 5 square equals 6 5 is 30 plus 50, we will get 80x plus 100 minus it was the 40, we will get 60y, and lambda square 5 square we will get minus 200. So this is our new equation by substituting the value of lambda, which but still this equation is not in the comparable form of to the standard equation. So we'll further modify this equation I'm writing above. So this equation can be written as x minus 4y plus 5 square of whole square into root under 3 square plus square equals right hand side 80x plus 60y minus 200 by root under 80 square plus 60 square into root under 80 square plus 60 square. So what we have done is to change it into the comparable form to the standard equation. We have divided it to the root under coefficient of x to the y, and to cancel this we have similarly multiplied with the same term, and here also we have done the same thing. So finally solving, on further solving we'll get 3x minus 4y plus 5 by root under 3 square plus 4 square to the whole square equals, now here it is if we will solve this then we'll get 100, and on solving this we'll get 5. So I'm cutting one step here. Finally we will get 100 by 5 square is 25, and this remaining term which is 80x plus 60y minus 200 by root under, so I'm simply writing this as 100 by 100. No need of this equation. So we got the equation which is comparable to the standard form, that is y square equals to 4ax. This let us suppose as equation 2, and here we can get a equal 4a equals 100 by 25, which is a equals 1, and x is equals to 80x plus 60y minus 200 by 100. So these are our required values which will be used further on finding the things which were given in the question. So now let us move to the things we have to find out. So we need these things. We don't need this actually, so I'm omitting this. And so first of all, we have to find out the axis, the equation of axis to the parabola. So for that, what we have to do is, from equation 2 we have to equate the value on the left hand side to 0. So on equating that, I'm supposing it as a. On equating that, we'll get the equation axis to parabola, that is 3x minus 4y plus 5 is equals to 0. So this was our first thing. Second is tangent at vertex. So equation of tangent at vertex can be found out by equating the term or the thing on the right hand side to 0. So finally, after doing that, we will get 80x plus 60y minus 200 equals 0, and on further solving we will get 4x plus 3y minus 10 equals to 0. So we found out two things. Now moving on to the third thing, so this is troubling me. I think I should write this. I think we don't need this thing, so I omitted it. Now moving on to the equation and length of latus rectum, let us suppose as 3. So first of all, I am finding the length of latus rectum. Length of latus rectum, that is 4a. We have which is equals to 100 by 25. 100 by 25 is equals to 4. So we found out the length of latus rectum. Now what do you have to do? The equation of latus rectum. Equation of latus rectum, that is x is equals to a. What is x? X we have, so I'm little modifying this. We will get 4x plus 3y minus 10 by 5. So that is, here I am writing 4x plus 3y minus 10 by 5 equals, the value of a is 1, where we found earlier. So 4x plus 3y minus 15 equals to 0. This is the equation of our latus rectum. Now what we have to do is find the coordinate of vertex and the focus. And to find the coordinate of vertex, what we have to do is we have to solve this and this equation. So on solving equation of axis and tangent, we will get the coordinate of vertex. So you can manually solve this, or simply use the calculator. So we are solving this 4x plus 3y minus 10 equals 0. On solving this, use the calculator, that will be much easier. On using calculator, I have already solved it. So the vertex is 1, 2. So this is our vertex, and the second thing is to find the focus. And to find the focus, what we have to do is we have to solve the equation of this axis again, and the equation of our latus rectum, this. So for vertex, oh sorry, for the focus, sorry, for the coordinate of focus, we are solving equation of axis and this equation of latus rectum, which is 3x minus 4y plus 5 equals 0, and 4x plus 3y minus 15 equals 0. And again we are using the calculator. We will get that the focus is 9 by 5 and 13 by 5. I have already solved it, so I can remember the value. So this was all, and this much I think we found everything. So thank you.